The compounds which are derived from minerals are known as inorganic compounds. The chemical compounds which are directly or indirectly derived from living organisms, that is, plants or animals, are known as organic compounds. All organic compounds have carbon and hydrogen atoms, and hence these are also known as hydrocarbons. Catenation. The property of atoms of the same element getting linked, forming longer chains, is called catenation. Atomic number of carbon atom is 6. The electronic configuration of carbon is 2,4. Carbon has 4 electrons in the outermost orbit and hence it is tetravalent. It could gain 4 electrons or lose 4 electrons to attain stable electronic configuration. To overcome this, carbon undergoes bonding by sharing its valence electrons. This allows it to be covalently bonded to 1, 2, 3 or 4 carbon atoms. Thus, it shows a high degree of catenation. Its tetravalent nature also allows it to link with 4 other monovalent atoms like hydrogen. The shared electrons belong to the outer shells of both the atoms and lead to both atoms attaining the noble gas configuration, resulting in the formation of covalent bonds. Thus, hydrocarbons are abundant in nature. Let us see how carbon forms single bonds in methane. Methane or marsh gas is the simplest saturated hydrocarbon. It contains 1 carbon atom. Its molecular formula is CH4. Since carbon is tetravalent, it needs 4 more electrons to complete its outermost orbit to become stable. Hydrogen has 1 electron in its first shell and requires 1 electron to complete its duplet like helium. To complete its octet, 1 carbon atom shares its 4 outermost electrons with 4 electrons of 4 hydrogen atoms. In this process, 4 CH bonds are formed. Bonds formed by sharing of electrons are known as covalent bonds. A single covalent bond is formed by sharing of 2 electrons. In this structure, the electrons of carbon are represented by a cross and the electrons of hydrogen by a dot. This type of representation is known as electron dot and cross structure. Some properties of organic compounds containing covalent bonds are: melting and boiling points of covalent compounds are low. Compounds containing covalent bonds are generally soluble in organic solvents but are insoluble in water. They are poor conductors of electricity and heat. A double covalent bond is formed when 2 pairs of electrons is shared between 2 atoms. For example, the atomic number of oxygen is 8. Hence, its electronic configuration is 2, 6. In order to attain a noble gas configuration, it shares its 2 electrons with another atom of oxygen, forming a double covalent bond. Hydrocarbons, the fundamental organic compounds. Some of the hydrocarbons also contain oxygen, halogens, and sometimes nitrogen and sulfur. In general, the hydrocarbons can be classified as open-chained or aliphatic hydrocarbons and closed-chain or aromatic hydrocarbons. The open-chained hydrocarbons can be saturated or unsaturated depending on the types of bonds present in the molecules. Saturated and unsaturated hydrocarbons. A hydrocarbon in which all carbon-carbon bonds are single bonds are called as saturated hydrocarbons. They have all the hydrogen atoms possible according to the alkane general formula CnH2n plus 2. A hydrocarbon that contains carbon-carbon double bonds, that is, the alkenes, or triple bonds, that is, the alkynes, are called as unsaturated hydrocarbons. They have less hydrogen content than saturated ones. Parent hydrocarbons. Methane, CH4, is a saturated hydrocarbon and an alkane. If we increase the number of carbon atoms by 1 and the number of hydrogen atoms by 2, then we will get a compound C2H6. This is ethane and is the next member in the family of alkanes. If we add 1 more carbon atom and 2 more hydrogen atoms to ethane, we get the compound propane C3H8. From this, we can infer that the general formula of alkanes is CnH2n plus 2, where n is the number of carbon atoms. Straight chain and branched chain. If we take the example of pentane C5H12, we can see that different structures are possible. In the above compound, the carbon atoms are linked together in the form of open chain. These compounds can also have branched chain. Compounds with identical molecular formula but different structure are called isomers, and this property is known as isomerism. Thus, these 3 structures are isomers. When the 2 ends of the carbon chain get bonded, forming a closed structure, then the compound formed is a cyclic hydrocarbon. For example, cyclohexane C6H12 is a cyclic hydrocarbon. Structure of benzene C6H6. Benzene ring consists of a cyclic structure made up of 6 carbon and 6 hydrogen atoms. Each carbon atom is bonded to another carbon atom on one side with a single bond and a double bond on other side. Functional group. The atom or group of atoms in the molecule which determines the characteristic properties of an organic compound is called the functional group. Homologous series. A series of organic compounds having same general molecular formula, same structure with similar chemical properties, and in which successive members differ by only one CH2 unit is called a homologous series. The members of a homologous series are called homologues. Some important characteristic of homologous series. All the members of a homologous series have same general formula. All the homologues consist of same functional group. Chemical properties of all the members of same homologous series show close resemblance due to presence of same functional group. Physical properties such as density, melting and boiling point, etc. show a gradual change with increase in molecular weight along the series. Molecular formula of two consecutive members of the homologous series differs from each other by a methylene, that is CH2 group, and the difference in molecular weight is 14 units. Nomenclature of organic compounds. IUPAC, International Union of Pure and Applied Chemistry, is the latest and widely accepted system for nomenclature of organic compounds all over the world. It has set certain guidelines for systematic nomenclature of organic compounds. According to this system, all organic compounds are considered to be the derivatives of saturated hydrocarbons, that is, alkanes. The name of a compound can consist of three components: root, suffix, and prefix. Root. This indicates the number of carbon atoms in the longest continuous chain. The root word for a compound with one carbon atom is meth. That with two carbon atoms is eth. One with three carbon atoms is prop. A compound with four carbon atoms is bute. One with five carbon atoms is pent. That with six is hex. One with seven carbon atoms is hept. That with 8 carbon atoms is oct, and so on. Suffix. This includes the phrase after in the name of organic compound and has two parts, suffix 1 and suffix 2. Suffix 1 indicates the saturation or unsaturation in the carbon chain. The suffix for an alkane is ane. For alkene is ene. And for alkyne is ine. Suffix 2. This indicates the presence of type of functional group. The suffix for an alcohol is -ol. For an aldehyde is -al. For a ketone is -one. For carboxylic acid is -oic acid. Prefix. It includes the phrase before in the name of organic compound. This indicates the substitution of hydrogen atom H from the basic carbon chain by any halogen fluorine, chlorine, bromine, iodine, or branching, methyl, ethyl, etc., and their position. Numbering. The numbering of carbon atoms in the chain is done in such a way that the first carbon is nearest to the functional group or branching or double or triple bond. The position of unsaturation and functional group is indicated along with the suffixes. Example 1. Let us name the compound C2H5OH. Steps. 1. For the root name, count the number of carbon atoms in the longest continuous chain and number them. In this example, only one chain is there with 2 carbon atoms, and thus the root used is eth. 2. Suffix 1. As all the bonds between carbon atoms are single, the first suffix is ane. 3. Suffix 2. The presence of functional group OH, that is alcohol, will replace E of ethane by all. Thus, we can call it ethanol. As the alcoholic group is attached to the first carbon, the name of this compound is ethane 1-ol. Example 2. Give the IUPAC name of following compounds. Solution. We will observe the following steps. 1. For the root name, count the number of carbon atoms in the longest continuous chain and number them as per rule. In this example, there is only one chain with 3 carbon atoms. Thus, the root used is prop. 2. Suffix 1. As all C-C bonds are single, suffix 1 is ane. Thus, it can be named propane. 3. Suffix 2. As the compound does not have any of the main functional groups, the name will remain propane. 4. Prefix. Hydrogen atom at the second carbon is substituted by a halogen bromine Br. Thus, prefix bromo along with its position will be mentioned in the name, that is 2-bromopropane. Hence, the final name of the given compound is 2-bromopropane. Solution. We will observe the following steps. 1. For the root name, count the number of carbon atoms in the longest continuous chain and number them as per rule. In this example, there is only one chain with 4 carbon atoms. Thus, the root name is bute. 2. Suffix 1. There is one double bond between first and second carbon atoms. Hence, suffix 1, ene, is added to the root word, making the name butene. As the double bond is present between C1 and C2 and the lesser number is C1, therefore the location of double bond is 1. The name of the compound will be but1-ene. 3. Suffix 2. As no functional group is present, there will not be any further change in the name. 4. Prefix. There is no substitution of any halide or alkyl group, so no further change in the name. The final name of the compound is but1-ene. Chemical properties of carbon compounds. Combustion. All hydrocarbons get completely oxidized to give carbon dioxide and water when burnt in presence of air or oxygen. This reaction is exothermic as large amount of heat is liberated. For example, methane and butane burns in presence of air to give carbon dioxide and water, liberating a large amount of heat. Incomplete combustion of hydrocarbons gives carbon monoxide, and in a very limited air supply, carbon black is formed from methane. Saturated hydrocarbons burn in air with a clean flame, whereas unsaturated hydrocarbons burn with a sooty yellow flame with lots of carbon black. The fuel used at home, vehicles, etc. consist of hydrocarbons which burn in air, providing energy for the related task. Hydrocarbons used in fuel for vehicles consist of sulfur and nitrogen also, which form their corresponding oxides when burnt in air. These oxides cause air pollution. Addition reaction. In addition reaction, an atom or a group of atoms is added to a molecule of hydrocarbon, giving a single addition product molecule. This type of reaction is characteristic of unsaturated hydrocarbons, where the addition takes place at carbon atoms with the double or triple bond. Addition of hydrogen. One molecule of ethene, which is an unsaturated hydrocarbon, adds a molecule of hydrogen, forming ethane, which is a saturated hydrocarbon, as product. Substitution reaction. This reaction is generally shown by alkanes, which are saturated hydrocarbons. In this type of reaction, one or more atoms in the hydrocarbon are replaced by atoms of the other reactant. Some important carbon compounds. Ethanol, C2H5OH. Its IUPAC name is ethanol. Common name is ethyl alcohol, and commercially it is known as spirit. Physical properties. It is a colorless liquid with pleasant smell. It is a combustible liquid with boiling point of 78 degrees Celsius and freezing point of -114 degrees Celsius. It burns with blue flame. Some chemical reactions of ethyl alcohol. A. Action of ethanol with sodium metal. Sodium metal replaces hydrogen from ethanol, forming sodium ethoxide with liberation of hydrogen gas. B. Action with PCl3. Phosphorus trichloride PCl3 replaces alcoholic group with chlorine, forming ethyl chloride and phosphorus acid. Ethanoic acid, CH3COOH. IUPAC name, ethanoic acid. Common name, acetic acid. Commercial name: vinegar. Physical properties: ethanoic acid is a weak acid with pungent smell. It is corrosive liquid at room temperature. Its melting point is 290 Kelvin. Its ice-like solidified mass is known as glacial acetic acid. Chemical properties of ethanoic acid. A. Reaction with halogens. Ethanoic acid reacts with chlorine, giving three types of substituted products, that is, monochloroacetic acid, dichloroacetic acid, and trichloroacetic acid. B. Reaction with metals. Metals like sodium or zinc react with ethanoic acid, giving their corresponding salts and liberate hydrogen gas. C. Reaction with alcohol. Carboxylic acids react with alcohols, giving esters. Ethanoic acid, that is acetic acid, reacts with ethanol, that is ethyl alcohol, in presence of zinc chloride ZnCl2, forming ethyl ethanoate, that is ethyl acetate, and ester.